Hello everyone, welcome to section 2.5. This is just, this will be a very short video. It's just the beginning information before we start getting into a little bit of proofs for the chapter. So we're not going to be doing the same level of proofs that we normally do, being that we're not in school, but we at least want to make sure you guys get the idea of what they're supposed to be. So these will be pretty simple and straightforward, mostly based on algebra. So in order to do proofs, it's all about a logical series of steps that leads to a conclusion that you can draw. So you're going to always be given some kind of information to start with. So you can be given a figure, it can have markings on it, you can be given a statement, but you have to base your whole entire starting point of your proof with information that you've actually been given that you know is true, and you kind of go from there. So the proofs that we're going to be doing, we're just going to set them up as 2-column proofs. Left-hand column is the statement, right-hand column is the reason. So the proofs are basically set up so that you say something, and over here is the reason, the property, the definition, the theorem, the postulate, whatever, that actually allows you to make that statement. The first statement you will always make in every proof is the given information, and the reason is because it's given. Then you start going into what can you do from the figure, what can you conclude from the given information, what relationship does that build, and you kind of go from there. And those reasons, again, tend to be the theorems, definitions, properties, etc. And then the very last statement is word for word what you were supposed to prove, and then your final reason. The thing about proofs is that they're very specific, very detailed, very kind of nitpicky. You really have to say everything, no matter how obvious it seems, and you have to actually say it in a statement. Even if the figure is marked with it, you still have to actually make a statement about it in the statement column. And that'll be more clear once we do an example. So the information that we are going to be using for proofs primarily in this chapter, and we're also trying to set up a little bit of the relationships that are going to be coming up in chapter 3, but since we're sticking kind of with algebra, most of our reasons are going to be properties. So you have addition, subtraction, multiplication, and division properties. Those aren't math operations. Those are really the idea. All of them are about doing the same operation on both sides of the equal sign. The reflexive property is when you have a shared piece. Again, that probably is not going to come up very much in the proofs that we're doing right now. Neither is the symmetric property, but that's really almost like if you have a mirror image in some way. Again, reflexive property we would use a lot more if we were doing chapter 4. Symmetric property we've really almost never used in proofs, but it might come up in your Math Excel assignment. The transitive property is this idea of a series of 3 equal statements. If A equals B and B equals C, then you can conclude that A equals C. Substitution property is just the idea if you have 2 things that are equal to each other, you can substitute in one for another. So you can substitute in for variables, you can substitute different expressions in to put variables where you need them. As long as you know that 2 things are equal, they can be substituted in for each other. And then the distributive property, which we already know. A lot of the definitions that we're going to be using are definitions of supplementary angles and definition of linear pair, again, depending on what you're given, because we know that relationship establishes that 2 things put together are equal to 180. And sometimes that's the only starting point you have, so you need to use it. Definition of a bisector, either a segment bisector or an angle bisector. This is important because it'll establish that 2 things are congruent. Either 2 pieces of a segment are congruent or 2 angles are congruent. Definition of midpoint is also used frequently if you're given that information because there's your starting point. You know that you have 2 pieces that are congruent. The angle addition and segment addition postulates that we did in chapter 1, Those are highly used as well because, again, it establishes a relationship when you're given a total of something or you're given two pieces and parts that you can put together for a total. Again, it's all about how you're going to set up an equation. Then the fact that vertical angles are congruent, that's important because, again, this will lead to you being able to set up an equation where one piece is equal to the other piece because those two angles are congruent. So this was just an overview of how we're going to start setting up proofs and some common reasons that you're going to be able to use to say what you're saying. And then the next section will be some example proofs.